All right, let's take a look at our next linear regression example. This time we're looking at a table that gives the height and shoe sizes of 6 randomly selected men. What we're going to do with this data is we are going to use Desmos graphing calculator to make a scatter plot, recognize the correlation of the data, find the equation for the trend line, the line of best fit, and then use that to answer the question. If a man has a shoe size of 10.5, what would be his predicted height? So the first thing we need to do is enter our data into Desmos. To make this fit a little better, I like to resize my screen so I can see my data and I can see the space that I need to enter into my table. So in box number 1, and if you have anything in here already, again, desmos.com/calculator, if you already have something in, hit the 3 bars and hit new blank graph. Make sure you always start from scratch. I want to hit add item and table. It will insert a table into box number 1. From there, I want to enter my shoe sizes into the X column and my height into the Y column. And I can do this one of 2 ways. I can go ahead and just enter all my shoe sizes first and then enter all of my heights second. Or I like to just use the tab button and go across the first row. I tab down, I go across the second row, and so on. So my first shoe size was 8.5. I press tab and I enter the first height of 67. So this first gentleman that had a shoe size of 8.5 was 67 inches tall. We make sure that that matches in our table. I'm going to go ahead and just enter the rest of the data. And again, I'm using tab every time I want to go to the next cell, whether it's to move to the right or to move down to the next line. I want to just double check my data real quick, make sure there's no number errors. It's easy to mistype something. All right, things look okay. On my scatter plot, I don't even see any of the data over here. I don't see any green dots, and they should be green because my color up here says green. So to see everything, I have to hit this little magnifying glass that's called Zoom Fit. When I click that, it'll resize my screen so that I can see my data. Now, this doesn't help me so much with the X and Y axes, but it does help me look at the data and recognize that it has a pretty strong positive correlation here because my points line up quite nicely. Not perfect, but pretty good. I'd estimate my R value, my coefficient, to be somewhere like 0.9 something. It's really strong, so probably like 0.99. Next, what I'm going to do is I'm going to perform the linear regression using that code from class. So think of it as y equals mx plus b, but instead of the equal sign, we're going to put that squiggle. So I do backspace, and I hold down the shift button and push the key next to number 1. Will give me that squiggle. Then I also need to tell Desmos that I don't just want x and y in my equation. I want it to call the data from x1 and y1. So I just have to put little 1s after both the x and the y in my formula. When I do that, it draws my trend line for me so I can see it a little bit better. And it also gives me the numbers that I need down here. The R value is listed, not R squared, but just R equals 0.9972. That's one of the numbers that I need. So our value was 0.9972. I'm also supposed to find the equation for my line of fit, my trend line, and then use that equation to predict the height of a man who has a shoe size of 10.5. So let's start with our equation. I have everything I need right here at the bottom of box number 2. I have the slope of the equation, the slope of the line, and the y-intercept of the line. So I just need to type it in y equals mx plus b format. So I'm going to replace m with a number 2.36134. And I'm getting that from right above here. M equals 2.36134. I'm going to replace b with 47.1828. Okay, just getting that from up above. So y equals mx plus b is my model. I know this, my line of fit now is red because it's actually graphing this equation, not just the trend line. If I turn them both off, we hide them both. Here was the equation that was given to us as a trend line when it was calculated. And then I'm going to turn on the red line, which is the line using the slope and the y-intercept provided up above. There it is. It's the same thing. And it should be because we typed the exact same numbers. So I'm going to go ahead and copy this. Make it a little bit easier. There we go. Spread this out a little bit and looks good. So last thing we have to do is make a prediction. Not just a guess, but actually use the data. So our data and our process of linear regression gave us our equation of the trend line. So this is the equation that we could use to predict other values. So what we have here is we have a man with a shoe size of 10.5. Okay, so that's the part that's given to us. Shoe size is the X value. It's asking us to figure out what is his predicted height, which would be the Y value. So we're going to go ahead and take this equation and we are going to replace the shoe size, or X, with 10.5. I'm going to use parentheses here to show that it's still multiplication. It's Y equals M times the X plus B. And then I have to do a little bit of math. So you grab your favorite calculator. I'm going to go ahead and just grab Desmos, because actually here in Desmos, I can just replace this with 10.5 using parentheses as well. Oop, not X. There we go. So M times 10.5 plus B gives me about 71.97687. Now that's my final answer, but I want to make sure that it makes sense. What does the Y represent? What were we predicting here? We were trying to predict the height of the man that has a shoe size of 10.5. And look at all of the other heights are given in whole number increments or half inch. So it looks like we're rounding to the nearest half inch in this case. So I would want to round this to 72 inches. So based on our data, if a man had a shoe size of 10.5, his predicted height would be 72 inches. And again, we did that using our equation.